In this video, we will look at the derivatives of logarithmic functions, the applications of the rules to some various examples. There is an assumption that you are familiar with the properties of logarithms. So as you see now on the video, these are the properties of logarithms that you're responsible to know. These properties come from a pre-calculus class or a prior mathematics class that you've had that used logarithmic and exponential functions and their properties. Throughout the questions that we see today, we'll be using these properties, and I'll make sure that I reiterate them as we go along, but please make sure that you're comfortable with them, and if you haven't seen them in a while, write them down so that way you have them in your notes. So the first thing we want to look at are the derivatives of logarithmic functions, the basic rule. So let's say you're given y is equal to ln x. Well, the derivative cannot follow the same power rule, the x to the n rule, that we used before because there is no x to the n, and even so it has a whole different makeup. The derivative of ln x is 1 over x, and x just has to be positive. Just have to be mindful that x should be a positive number. The proof of this has been shown in a previous video that you can go and examine to, and I'll put a link to at the bottom of this video. Now, what if it's not just x, which is usually not? It's like it's ln of some greater function. If that is the case, we use the chain rule. Because remember, the chain rule is the derivative of the outside times the derivative of the inside function. So the outside function here would be ln of something. So the derivative would be, what's the derivative of ln? Well, the derivative of ln is 1 over the inside function times the derivative of the inside, u prime. This is used quite often when you're asked to differentiate logarithmic functions, because more often than not, the function that ln is acting upon is not just x, but something greater, something more complex, a more complex polynomial. So we're going to apply these now to some examples for you to get some practice with them. So here are two examples that we will apply the rule for the differentiation of logarithmic functions. If we have y is equal to 5 ln x, it's 5 times ln x. So you want to think of it as if we had a question like 5x squared. You would take the derivative with the power, x to the n, the power rule would be the 2 times the 5, and then what's the derivative of x to the second? Well, same here. Think of this as 5 times the derivative of ln x. The derivative of ln x is 1 over x. So your answer is 5 over x. So your derivative is 5 over x. Let's look at this question. Now this question are those more complicated examples where it's not just ln x, but ln x is part of another tool that we use for differentiation. In this case, it's the quotient rule. Notice that you have a fraction here. So remember what we were talking about in previous videos is that you want to look at what the bigger function is. And the bigger function here that you're looking to take the derivative of is a fraction. So if it's a fraction, you're going to want to use the quotient rule. So quotient rule. So your numerator is your u, so your numerator is ln x. Your denominator is your v. The derivative of ln x is 1 over x. The derivative of x squared is 2x. So notice that in this question alone, we've incorporated quotient rule, the derivative of logarithmic functions, and the x to the n rule. Now, applying the quotient rule, remember, make sure you know your rule. U prime v minus uv prime all over v squared. Subtraction. U prime is 1 over x. V is x squared. Minus u ln x. V prime 2x all over v squared. So that's, v's already x squared, right? So you're going to square that. Let me just partition this so we see that's not part of our solution. Notice that right here, the x squared times the 1 over x, they're being multiplied with each other, so you can simplify that. So I get x for the first term. This is going to stay 2x times ln x. So I'm going to write that as minus 2x ln x. And x squared squared, using your properties of exponents, when you raise a power to a power, you multiply them. So you get x to the fourth. You can simplify a little more. In the numerator, you have a greatest common factor. The greatest common factor is x. That same x is an x here, a factor in the denominator. So if I factor out an x, I'm left with 1 minus 2 ln x all over x to the fourth. Notice that the x that I factored out was here because that was the factor. Now this leaves me with x to the third. So my final answer, y prime, is 1 minus 2 ln x all over x to the third. Let's try a few more examples. Y is equal to ln of x squared plus 1. Now notice how this is different. This isn't just ln x. This is ln of a greater function, something that's not just a monomial, and that's just x. So remember, if you look up here, you think of this as ln u. So this becomes your u. So the derivative is 1 over the u, the original, times the derivative of the inside. So y prime becomes 1 over x squared plus 1 times the derivative of the inside. And the derivative of x squared plus 1 is 2x. And you can write that with the 2x as the numerator. And that's your derivative. Similarly, if we look at this next example, you have an ln of a u here, but you also have a bigger function that's not just an ln, it's a product. Notice you have x squared times ln. So you have to make sure that your bigger function, what you do first, is a product rule. So your u is x squared, your v is ln of 4x plus 2. Your u prime is 2x. Your v prime is now when you use the rule of ln u. So make sure you can itemize what you're doing each time. So the first thing is product rule, piece, and then once you peel away that layer, then you look, okay, look, it's ln of u. So ln of u becomes 1 over u times u prime. So it becomes 1 over 4x plus 2 times, what's the derivative of that inside? 4. So I usually just clean it up a little. V prime is 4 all over 4x plus 2. Now product rule. Not new. Product rule is u prime v plus u v prime. And all you do is you substitute those terms into the product rule. U prime, 2x, v, ln of 4x plus 2, plus u, x squared, v prime, 4 all over 4x plus 2. I notice that amongst the two terms here, before I even start to clean it up, here's one of the terms, here's the second term, I have a common factor of 2x. Don't always have to simplify to that extent, but let's see if that gives us anything. So if I take out the 2x from the first one, I'm left with ln of 4x plus 2. When I take out a 2x from here, I'm left with another 2x, 4x plus 2. And that would be your final answer. If you left it as 2x ln 4x plus 2 and then the 4x squared just as one numerator, all over 4x plus 2, that would be a fine answer as well. But again, realize what we did here. You first look to see what the big picture is. It's a product. So that tells you product rule. And then you break up the pieces, and then in the piece is the ln u rule. So you have to just look to see what the big picture is first before you even continue on with answering the question. And always do that. Every time you get a question, is it product? Is it quotient? Is it x to the n? Is it chain rule? Is it log? And then from there, you can continue going on.